Okay, you are going to be introduced to radian angle measure. Up until today, when you were measuring angles, you've only known one thing, and it's degrees. And you got a good concept of degrees. And around a circle, there's 360 degrees. Well, now we're going to talk a brand new angle measure. It's called radian, much more applicable to the real world. So we're going to learn what it is, and we're going to be converting back and forth. Real simple process. I will say this was on the SAT. Just given a radian angle measure, convert it to degrees. Because I get to go back and see everybody's test. I can see what everybody answered, so I know who got it right and who got it wrong. And it was on the ones that, because when you take this, I don't know if your PSAT had it, but the last like 5 questions are not multiple choice. You've got to generate an answer on your own and then bubble it in. And that was one of these here. So, and the only kids that see this are you guys that are in trig. And last year there were, I think, 23 juniors that had trig. Only 13 of them got it right. So, what that, and I know everybody could do it just like this, but it was October when we learned it. And then when April came along, they forgot it. So what we learned today is going in this little book, because it is a simple, simple process. So again, that SAT, it's not like you haven't seen the stuff, you've just forgotten it. So remind me to put it in here when we're at some point today. Don't let me forget that, because I probably will. So anyway, what's a radian angle measure? Okay, so a radian angle measure is equal to the number of radius lengths around the arc of a circle. Okay, doesn't sound too bad. So let me draw a few pictures to explain what that is. So let's say we had a circle whose radius was 4 centimeters. So if we were to mark off on the curve a distance of 4 centimeters, so I make this arc so that it's exactly 4 centimeters long, just estimating. So if I was to take now that endpoint and connect back, this pie piece created by the 4 centimeter arc, because that's equal to 1 radius length, this angle would have a measure of 1 radian. So this angle measure would be 1 radian, because the arc that's cutting it off is 1 radius. Okay, keep that thinking in mind. Stick with that same 4 centimeter circle. So this time, if I go 2 centimeters along the arc, and then create the angle by that arc, what do you think my angle measure is in radians? Skylar? 1/2 radian, because it's half a radius. So So this angle measure in here would be a half of a radian. And one more. So if I go 8 centimeters, all right, what's my angle measure this time? Adam? 2 radians big. Okay, so you have a concept of what a radian angle measure is telling you. It's telling you something about the arc length. Okay? So now we've got to tie this into degrees. What's going to be our conversion? All right, so my question is, first question is, how many radius lengths are there around a full circle? How many radius lengths are there around any circle? Doesn't matter how big the circle is. I could have a 4 centimeter circle. I could have a 10-mile radius circle. How many radius lengths are there around any circle? How are we going to figure that out? How many radius lengths around a circle are there? What are we talking about when we're talking distance around a circle? It's not a foreign concept to us. What do we call a distance around a circle? Circumference. So if I knew how far it was around the circle, I'd be able to tell how many radius lengths there are by dividing it in. What's the formula for circumference again? 5th grade. How do you get circumference? Circumference equals? Pi d. What's that formula in terms of radius? I like pi d because it's quick, short, and sweet, but we do want to talk radius length. How does this formula change when we change this to radius? 2 pi r. This formula is kind of giving it away right now, but you probably aren't seeing it yet. So let's do the circumference here. Circumference equals pi times diameter. We'll just go pi times diameter. So pi times 8. Somebody multiply pi times 8 for us. Give me an approximate. What are you getting? About 25? 25 point what? Okay, we'll go 133. Okay, so that's how many units around it is. If it's a 4, let's go centimeters. So how many sets of 4 fit into that? Divide that by 4. So if we went all the way around a circle, which we know is 360 degrees, how many radians is it around? How many lengths of the radius is there around there? About 6 point how many?
283.
So it's about 6.2 something radians around the circle. 6.3? Okay, all right. Well, that's a good approximate. It's about 6.3. Jimmer?
2 pi.
2 pi. Where'd you get 2 pi from?
When you divide the whole big long number
Yeah.
by 4,
Yeah?
2 pi.
You get 2 pi. Did your calculator tell you 2 pi?
Yes.
It did.
Yes.
Cheater calculator. No wonder you got that. Usually the calculators will give you decimals. He is correct. Take a look at our formula back here. The circumference is 2 pi radius lengths around. So it is exactly 2 pi. It's about a little bigger than 6 around a circle, about a little more than 6. A smidge over 6.28, blah-de-blah-de-blah, 6.3, but it's exactly 2 pi all the way around. So there's our conversion for us. Let me get a new sheet here. So that's how we're going to tie the radians to the degrees. So let's start with our 0 degrees. Obviously 0 degrees will have 0 radians. And then we just said if we go all the way around, we know all the way around to be 360 degrees. Jimmer's calculator gave us the cheater answer, exactly 2 pi radians. But again, 2 pi sometimes, well, how much is 2 pi again? So it's about 6.3 radians. Just to get a concept. 360 degrees is exactly 2 pi, that's about 6.3 radians. Well, let's go over to the 180 degrees. Exactly how big is that angle in radians? Skylar? 1 pi. If it's 2 pi all the way around, halfway around is exactly 1 pi, which is about how many radius lengths to get around there? 3.14. And then let's get the other common one up at the top. We know the top to be 90 degrees. What is that now going to be as an exact radian? If it's 1 pi over to 180, what's it going to be at 90? Half pi, pi over 2. That's exact. Well, how many is pi over 2? How many radius lengths is it up to that spot? What is pi divided by 2? 1 point something. About 1.6 radius lengths around there. Okay, so we got all kinds. Might as well finish it off down here. How many radians down at 270? Exactly, in terms of pi. 1.5. What's 1.5? They do all fractions, improper fractions. What's 1.5 as an improper fraction? Multiply, add 3 pi over 2. What is that decimal? What's 3 pi divided by 2? About how many? 4.7. So I told you about 4.7 radius lengths around to that 270 degree angle. Okay, so we've got all kinds of conversions here. We can use the 360 and 2 pi. We can use the pi over 2 and the 90. We can use the pi and 180. We could use the 3 pi over 2 and 270. The most common one to use is right here for converting degrees to radians. There are pi radians in 180 degrees. So we're going to do this. Convert degrees to radians. Let's start with 45 degrees. We just got to multiply by our conversion. Our conversion is, in 180 degrees, there are pi radians. So because I want to cancel degrees, I'm going to put it in the bottom. I want to get to radians, I'm going to put it in the top. So essentially, all we're doing is dividing by 180 and multiplying by pi. And we want to leave the pi visible. So all you've got to do is do 40. So it turns into 45 pi over 180. You've just got to reduce 45 over 180 any way you can. The calculator will do it if you just say convert to a fraction. You can do it by hand like you did in junior high. It doesn't matter, but the quick way is to let your calculator do the work. Oh, this isn't plugged in. Hold on. Did I turn that on? Oh, yeah, I did. So 45 divided by, is that on? Oh, you're coming on now. Alive. Or not. Oh, I got 1/4. I couldn't do that one in your head. So we're getting that pi over 4 radians. How do you turn it? It's under math. The very first feature on math, it'll say triangle frac. It says convert to fraction. Okay? Anybody else want to know? You good? Under math, right here. So I just got my decimal and I went to math and then. You don't have math? What do you got? Otherwise, you go back to junior high, divide by 5, whatever, until I get down to something. Well, it just takes a little while, but you could get there. Remember, there's one part of the SAT where there is no calculator. The whole one chunk of math is no calculator, and the second chunk is calculator. So you might have to reduce that by hand, but hopefully you've got that skill. Okay, so it's exactly pi over 4 radians. It's about how many? What is pi divided by 4? 0.79. So a little more than 3/4 of a radius length. So I want you to get a concept of what this is. So what I want you to do on your homework is show me a 45-degree angle. So just estimating. Oh, you could put it on the coordinate plane. I guess that'd be quick, easier. So 45-degree angle. I want you to mark it 45 degrees. I want you to mark it pi over 4. And I want you to mark it about 0.79. So what is that 0.79 telling me? It's about it's a little over 3/4 of a radius length. So if this was my R, my radius, so I shouldn't use R because that's radian. X, I'll call it X. So if that distance was X, I know that the arc length is about 0.79 of an X. Not quite a full radius length, about 80% of a radius. I want you to wrap your brain around what this number is actually telling you. I'm going for overkill this year instead of just this process. This is with homework. You're going to draw. It's going to give you an angle. You're going to show me how you get it in exact. Then you're going to get me the approximate. You're going to give me all 3 values. All 3 values are describing the same angle here. Yeah.
So no matter what the angle is, we can just use pi.
And 180. That's your conversion. It's like 12 inches in a foot. It's always there. Yes.
So we have to draw like a coordinate.
Yeah.
Circle.
Well, yeah. I'm gonna do overkill this year because it just irritated me that so many of them missed this on that test, and I just think there's no concept of radian other than a 2-step process of divide by 180 multiply by pi, which they forgot. Maybe it'll stick in if you actually know what it is, what it's representing. So let's try one more of these. Let's go with 220 degrees. convert that to radians and show me what it means. So again, we've got our conversion, 180 degrees, pi radians. I want the degrees to cancel, so it goes in the bottom, so we're actually dividing by 180, multiplying by pi, and then we work it out. So as an exact value, reduced down, (11 pi over 9). As a decimal, we're going to multiply 11 times pi divided by 9. I got to times that by pi. About 3.8. So showing me what that means on the circle. First 220. What quadrant is 220 going to land in? Third. 180, a little bit past. So there's my 220. I now can call it 11 pi over 9. And what's that representing? It's representing an arc length of about 3.8 radius length. So 220 degrees, 11 pi over 9, and about 3.8 are all marking the exact same spot on the unit circle. So are you good with going from degrees to radians? Oh, they do some ugly ones too, that we're not exact with. Can I get rid of this? Yes.
Hey, why did you do 0.79% and then 0.38?
0.79, that's how much of the radius length, because it's less than one full radius length, this arc. It's about 0.79 of it, 80% of the original one. This one's 380% of the original one, 3.8 of them. So there would be like 1, 2, 3, oh, I didn't do a very good job. But then the rest is 0.8, I went too far, that's why. So there's 3.8 of this length around the arc. Okay, when you get angles like this, let's say 280 degrees and 15 minutes. Well, we're not going to be exact on these ones. The ones that are just a whole degree, we're going to have the pi visible. These ones, we're going to go through that same process, divide by 180, times by pi, but we're going to get a decimal. We're not going to bother, they don't bother with the degrees a minute ones to go into an exact fraction. Who's ringing? Is that in here? Come on, Jimmer. You're worse than me. You must not get phone calls very often either. I leave my phone on it, something never rings. Alright, so this kind, we're not going to bother with the exact, we're just going to go right into the decimal. So 280 degrees, 15 minutes, divide by 180. I don't know if I need the degree. I don't think I need the degree mark. And then times that by pi. So about 4.89 radians. Was that weight in here? Am I hearing ghosts? Ghosts today? Alright. So, 280 degrees, that's swinging from the 0 all the way past the 270, about to there. .89 radius. So with the degrees and minutes, we're not going to bother with the exact number or fraction of pi. Okay, now can you go backwards? If I give you a radian, can you convert it back to the degree? Okay, so let's start with, say I had an angle measure of 7 pi over 20 radians. Any clue what quadrant that's in? Not me. That's really hard for my brain to wrap around and think where that's at. If somebody asked me where that is, I would definitely have to convert it to a degree of scale. I don't think our brain works with the fractions nearly as well as it does with the degrees. But it's the same process. I'm running out of ink. Change colors. What's our conversion factor?
Pi.
Pi and 180. Where's the pi going to go this time? Bottom. Okay. So we got, let's take care of it right away. What happens with those pi's? They're going to cancel. We don't really have to, those are going to cancel out. So all we really have is 7/20 times 180. So go ahead, let your calculator do the work, or do it by hand. 10, 1, 9, 63. So now I know it's in the first quadrant. 7 pi over 20 has no meaning to me until I turn it into something. So 63 is about here. That's 7 pi over 20. And if we wanted the decimal, we could multiply 7 times pi over 20. And that would tell us how many radius lengths around it is. So again, how many radius lengths is that? This 7 pi over 20, I have no idea. What is 7 pi over 20? Pi divided by 20. A little over 1 radius length, 1.1. 1.1 radian. Can I get rid of this one? Pi over 10 radian. So again, our conversion has 180 in pi. We're dividing by the pi to get rid of it, multiplying by the 180 degrees. So it's just flipped around. Out of radians, you divide by pi. Into degrees, you multiply by the 180. So the pi's cancel. What's left in its place up here? 1/10. Don't make that 10. That is 1/10 times 180. What are we getting? 18 degrees. So very small angle. And then what about 2.61 radians? Process doesn't change. You have to use your conversion. The conversion's 1 to 880 degrees is pi radians. So we're getting rid of the radians, so we're dividing by the pi. 180 degrees. So what do we got to do this time? Yeah, you actually have to divide by pi because there's no pi to cancel off. It's been multiplied in. It's our decimal version. So you actually have to do 2.61 times 180 divide by pi, and we'll go with a decimal. When it starts as a decimal, we'll finish. So about how many degrees is this? 149.5. Now I know where 2.61 radians would take me. About there. 2.61 radians. There is no symbol for radians. I mean, I was putting a little R underneath it, but they usually do no symbol for radians at all. So when it's talking about an angle measure and it doesn't have a degree, it's automatically a radian. Okay, I think, done. Okay, your assignment. I changed what was on that thing to match what we're doing. Okay, it's on here. Page 113. So the 35 to 45 odd, you don't have to make the sketch anymore, and these are going to be the approximates, so no pi visible in the answer. No pi visible. Okay, your SAT book, pull that out.
Sure.
Yeah.
Can you push up the tape a little bit?
Yep. This way?
Yeah.
Okay. So give yourself a page to convert degrees to radians, and then converting radians to degrees. Oops, scribble that out. So you can see I told myself what I'm doing. I'm going to multiply by pi and divide by 180. And I showed the T-box, so hopefully that's enough to refresh your memory on it. So you can look over this the week before you take that dumb test. Not dumb test, awesome test. Take that all back. It's awesome. Feel so smart when you're done. And then converting radians to degrees. Easy process, isn't it? Super easy, but like I said, so many mystics, I think you don't remember. So the whole point of this book is hopefully just to bring everything back to the front of the brain before you take it.